Alright, so in the last video we did the configurations tab and we went through all what we could configure. So right here we're going to go through failsafe. We're not going to be doing any PID tuning or advanced tuning, no JavaScript or programming. We're going to go next to the receiver to connect our transmitter. Now, so in the failsafe, it's quite simple. We're just going to have a delay in case we lose RX. So here you can see DS in deciseconds. You can see the DS here is equals to 1 second equals 0.1 second. So 0.5 seconds means basically 5 DS here. So if you lose RX, something is going to happen. And what's going to happen, you either have the drop or you can have learned. So if you also have GPS installed, you can also have return to home, which is where you're going to get your startup location and then it's going to return to you with different parameters. So if my drone loses RX, I'll rather it land and try to see if we can land safely using the gyro and accelerometer to level up. So drop, on the other hand, basically if you lose RX, you just basically going to just jump out of the sky. Simple as that. Now, by default, for example, in beta flight, you could have your drone lose RX, and it's going to hold the positions of the stick. So if my stick is all the way up as throttle while I'm pitching forward, if I lose RX while doing that, the last position of the sticks is what is going to hold. Now, all that there is actual problems because your drone could go really far away while doing that. Now here we have these two options. We have gone through that. You can have the throttle that you use for landing. This throttle is what you could configure for a much more smoother landing. So if you have 1000 as your throttle, basically you will not really have that much that much lift when landing down, so therefore you might land down really hard and damage your drone. So we're going to skip that delay in seconds there for this here, because return to home is basically what I would really choose if I lose telemetry, because telemetry is not really easy to regain telemetry with those type of systems, with those kind of receivers. Also, once you lose it, it takes a few seconds, and those few seconds is enough so that your drone could fall out of the sky or go far away. So once telemetry is lost, I'd rather have return to home immediately, so I have it quite soon. So I can have return to home for a GPS module, or I could have do nothing, and do nothing will just generally keep on those procedures here and ignore GPS. So this basically is the fail-safe minimum distance, and here you can have actually what you want here. So you can have return to home or none, or you can have land. So that's basically the fail-safe, and I'm going to not put any fail-safe right here until it's time for actual flight. But what I'll really do, basically I'll have it try best to land. Now I don't want to save and reboot. I don't have time for the rebooting. I'm gonna go straight to the receiver here. Now it's going to be a very short video because that transmitter is already connected to that receiver from Betaflight while using Betaflight, but in essence it has a binding code, and that binding phrase is the same as what's on the transmitter, and it has the same regulatory domain that corresponds to the transmitter. So it basically will always connect automatically. But when you have a FPV drone and you flash it to Inav, so like I said in the last video, this flight controller on my drone is generally built in with Betaflight, but now I converted it to Inav, and there's so many things I have to do. So when you have your receiver tab located, you're going to leave channel map as auto, well, default. RSSI source, we don't have that. We don't have any receiver being controlled via any of our buttons on our TX, so we're not going to have that. Here we're going to have the receiver mode. We're using serial. we'll be using the serial RX in the ports tab. We're going to be using Crossfire because we're using a ELRS which uses Crossfire protocol. And here we're going to have serial ports inverted. So comparing to protocol default, we're going to have it on. Now we have our receiver wire from our receiver going to our T wire or our T terminal on our flight controller, and we have our transmission wire on our receiver going to the receiver terminal on the flight controller, and that there is an invert, so therefore I'm going to have that inverted. That's how I understand it, and hopefully that it is 100% accurate. So we have serial receiver have duplex. No, we're not going to be enabling that, and that's generally all that's going right here. So you have RFCs moving, and we're going to ignore all that, but here we're going to have throttle MID, throttle expo. You have the RC dead burn and your dead burn, and it gives you all the information here when you hover over it to tell you what it is. And not be going into anything advanced here. I'll just leave it as it is here. So all you have to do here, select your type of connection. Mine is serial RX, with I'll choose serial. Select your provider. If you're using the S bus or if you're using FreeSky, you might be using either S bus or using iBus and this kind of stuff, or FPort, but I'll be using Crossfire because I'm using ELRS which uses Crossfire. I'll leave that on, but you see that your receiver actually shows your different channels here, and it shows your different yokes right here, and you see it does not move, and you know that you are binded. Then therefore what you have to do, change that from on for reverse and to put it to off. So I'll click on save and reboot right here, and then I'm going to now see whether or not my receiver will connect. Currently my drone is in a binding mode, so you see here everything is flush. So the first thing I'll do before changing that to off is I will turn on my receiver, which was obviously the first thing, and I'm going to restart my drone. So I just reconnected my drone. My receiver should now be out of binding mode because it automatically goes there, and I now have telemetry and now have connection here. On the receiver on the screen, I can see nothing here moves, so then I'm going to switch that to off and then save and reboot. So here in my receiver menu with serial ports now switch around, I don't do any hardware thing, I just turn from on to off. I see everything works here. Those are my throttles. So this is my throttle here, this is my roll, this is my pitch, and this is my yaw. Now from what I've realized, my yaw is my drone rotating left or right on the x-axis, so that they have to be inverted right there, but for now I'm going to leave it like that. So switches work, and everything works as my channel on here. So that's generally it for this video, guys. So this is how you configure a receiver in Inav, and from there we'll be going to modes to be able to arm, and then we're going to go to another menu and see what's available. So see you in the next video.